This video is on how to calculate the mass of a sample if we're given the number of moles, okay? So we're looking for the mass. Oops, there we go. Looking for the mass, and we're given the moles, so we're converting from moles to grams, okay? And the way that we do that is we use the molar mass, okay? So we're going to use the molar mass to convert from moles to grams or grams to moles. And so the first things I got to do is I'm going to figure out what my chemical is. It's calcium chlorate. So calcium is +2, chlorate is ClO3 with a -1 charge, so it's CaClO3 parentheses 2. So I have to calculate my molar mass from the periodic table. So I have 1 calcium, so it's going to be 1 times the molar mass of calcium, which is the average atomic mass in grams per mole, so 40.078 grams per mole. Then I have 2 chlorines, so it's 2 times 35.453 grams per mole. And your numbers, your molar masses may be slightly different depending on what periodic table you're using, and that's not that big a deal. So don't worry about if your numbers aren't exactly the same. And then we have 6 oxygens, and that 6 comes from that calcium with those that chlorate is in parentheses. So that 2 applies to the chlorate. So there's 2 of those chlorates is what it's saying. So it kind of goes like that. We got 2 chlorines and then 3 and 3 gives us 6 oxygens. The other way you can look at it is when you have parentheses around something, any subscript on the outside, you multiply on everything that's on the inside. So 2 times 1 right there gives me 2, and 2 times 3 gives me 6 oxygens. Okay, so that's going to be 6 times 15.999 grams per mole. And then we're going to calculate all those and add them together. And when we add them together, we get 206.978 grams per mole. Okay? Now, that's going to be my molar mass of calcium chlorate. So, to figure out the mass of this many moles, that's the mass of 1 mole. So, to figure out what the mass of 6.43 moles is I'm going to write 6.43 moles of calcium chlorate. I'm going to use dimensional analysis. Okay? And dimensional analysis is basically a way to convert from one unit to another. So here we're converting from moles to grams. And so we need a conversion factor using our molar mass so that we have 2 things that are equal to each other. So if you look at our molar mass, it's 206.978 grams per mole. So that's that many grams in 1 mole. And so I take that molar mass and I rewrite it as 1 mole of calcium chlorate is equal to 206.978 grams of calcium chlorate. Okay? And then I can use that in my dimensional analysis. Now, when you do dimensional analysis, you're trying to get these units to cancel out. So I'm trying to get moles of calcium chlorate to go away. And so to figure out what goes in the bottom, what goes on the top for my molar mass, I'm going to take the moles of calcium chlorate and put that in the bottom. I'm going to put my grams of calcium chlorate on the top. Okay, so that it'll all cancel out. And I'm going to erase some of this so that I can have a little more room. It makes a little more sense. Okay? And then so I have moles of calcium chloride on the top divided by moles of calcium chloride, so it cancels out, it goes away. Okay? So when I do dimensional analysis, whatever number is on the top, I'm going to multiply by. So this 206, it's on the top, so I'm going to take the 6.43, I'm going to multiply it by 206 0.978. That gives me 1,330.86854 grams of calcium chloride. Okay? Now, significant figures. Now, I'm going to look at basically my numbers. This 6.43 has 1, 2, 3 sig figs in it. My 206.978 that has 1, 2, 3, 4, 5, 6 sig figs. Whenever you do multiplication or division, you go by the least number of sig figs. So that 6.43 has 3, that's the least number. So I'm going to count over 1, 2, 3. I'm going to round it at that 3. So that 1,330.86854 becomes 1,330, no decimal point, grams of calcium chloride. And that would be my final answer. Okay? The next problem. What is the mass of 10 millimoles of dichlorine monoxide? Same problem as we did before. The only difference is that we don't have moles. We have millimoles. Okay? And so we have to take those millimoles, convert them to moles, and then take the moles and convert them to grams using the molar mass. Okay? So we have to figure out a conversion factor for moles to millimoles. Right? So I'm going to start off with my 10.00 millimoles of dichlorine monoxide, so Cl2O. And milli means basically 1,000th. Okay? So a millimole is 1,000th of a mole, so it takes 1,000 millimoles to equal 1 mole. So 1 mole is equal to 1,000 millimoles. And so I have millimoles on top, and so I want millimoles on bottom so that it'll cancel. So the 1,000 is going to stay with the millimole. So 1,000 millimoles of dichlorine monoxide is equal to 1 mole of dichlorine monoxide. So my millimoles cancel out. If I stop right there, I have moles of dichlorine monoxide, but I want grams. I want the mass. Okay? So I have to calculate the molar mass of dichlorine monoxide, so Cl2O, so 2 chlorines. So it's going to be 2 times the molar mass of chlorine, which is 35.453 grams per mole. And then 1 oxygen, so 1 times 15.999 grams per mole. We calculate that out, add them together, and we get 86.905 grams per mole. So then I have to write that as conversion factor. It's that many grams in 1 mole. So I'm going to write that as 1 mole of dichlorine monoxide is equal to 86.905 grams of dichlorine monoxide. Then we're going to put that in our dimensional analysis. Now I have moles of dichlorine monoxide on the top, so I want moles of dichlorine monoxide on the bottom. And the number, right, it all stays together. So in my conversion factor, in my equality, the two things that are equal to each other, I have 1 mole of dichlorine monoxide. So that's what I'm going to put on the bottom. 1 mole of dichlorine monoxide, so that it'll cancel with the one that's on top. And then I put the mass, the molar mass part, 86.905 grams of dichlorine monoxide on the top. And so that cancels. Then I'm ready to solve it. So when you do dimensional analysis problems, right, you can take everything on the top, multiply it together, take everything on the bottom, multiply them together, and then take the top divided by the bottom, because it's just one big fraction. A better way of doing it is doing it by step by step. So what I'm going to do is I'm going to take 10.00 right here, and then I'm going to go to step 1, and I'm going to divide it by 1,000. Divided by 1,000, I hit enter, get an answer, and then I go to step 2. And since this is on top, I'm going to multiply it by it, so times 86.905. I hit enter, and my answer is 0.86905 grams of dichlorine monoxide. My final answer, my rounded answer, because 10.00, those are trailing zeros with a decimal point. That's 4 significant figures, 1, 2, 3, 4, and then that 1,000, that's an exact number, so it has an infinite number of sig figs. We don't look at that one. Then 86.905, that has 5 sig figs. I go with the least number of sig figs, so that's 4, and so I'm going to go 1, 2, 3, 4. Okay? Now, in science, the next number over is a 5, but it's not 5 something, it's exactly 5. A 5 and no other digits. Okay? To be exactly 5, it has to be a 5 and no other digits, or a 5 and nothing and just zeros. Okay? So when it's exactly 5, right? That's not greater than 5, that's not less than 5, it's exactly 5. You round that number right there, that 0, right? In this case, so that it's even. All right? So 0 is an even number, so 0.8690 grams. It doesn't round up to 1 because it's not greater than 5, it's exactly 5. And so you get 0.8690 grams is your final answer. And that's how you figure out the number of grams from the number of moles.